classes, would you like another bonus opportunity each 9 weeks, or again, something that relates? I thought it was really cool. I was impressed with who did what. But back in the beginning, would you have told me this side decreases or increases? Decreases, all right. What about this guy? Increases. And what was this guy? Okay, so you guys are good to go. You know this stuff. We're just going to talk about the theory. So this is increasing. This guy was decreasing, and you said this guy was a constant. Okay, but when we talked about that, we never talked about what was happening with the coordinates on this. Tonight, all you're going to do is finish the packet and the odds, and I will put that back up. You could do the evens for bonus. Tonight, you're going to talk about increasing and decreasing like we have, but I just want to hit the, just the theory behind it, I guess. So we can say a function is increasing on an interval if for any two values your first x is less than your second x. So if I pick these 2 points, would you agree that this x is smaller than that x because it comes first? Do you agree? Like this x would be maybe 2.2, this x would be around 3. So that's why it's increasing, when the first x is smaller than the second x. And if I plug those x's in, this y value, so this y would be like 4, would be smaller than that value. Technically, that's why it's increasing. We just always looked at the graph. But now that you're super smart, when you get to calculus, you're going to use the derivatives and tangent lines and slopes to examine that further. But the function increases. Do you agree? Can anybody tell me at what point the function's increasing? From who to who? Well, I'll give you a hint. It's going to infinity. Where does the increase start? 2, what'd you say, 2, 3? Yep, and I'm thinking we'll just make it easy and say around 2. Does that make sense? Remember, unless it was an endpoint, we always use our parentheses, not brackets. God bless you. We are decreasing if our first x, and I think this is a typo, and correct me, God bless you if I'm wrong, is greater than our second x. So if this is our first x and this is our second x, isn't negative 3 greater than like negative 4 or 5? So I think that was a typo. And then when I plug them in, this y of the first one would have to be less than this one. So I really think that those two were typos. But this interval, remember your lower bound comes first, is negative infinity to, I think, negative 3, if I'm looking at it right. And then we have the constant. That's when the y's are always the same. No matter what x I plug into, my y's are always the same. What interval are we constant at? Can anybody see that on theirs? What do you think, Kaylee? Negative 3 to 2. Even constant, we use parentheses. The only time we would use a bracket is if this was an endpoint, not an arrow. So tonight, on your homework, you can tell me increasing, decreasing. That's it. You know how to do it. But then we're going to talk about our maxes and mins. I disagree. Every time I do this, I see more and more wrong with these notes. But do you agree these top ones are the maxes? Right? And then the bottom guy is the min. This is where it would be a degree 4. We would have 3 turns. But when you talk about a relative max and min, and again, we're just going to pick them out like normal, but talking about the theory, it says, okay, if this maximum point, do you agree he's at 5? what the relative max and min say is, if I plug in that maximum point to whatever equation and find the value of it, it would be bigger than whatever x it occurs at. So it would be bigger than when I plug in -2 and get 5. So if I took that max and plugged it back in, it would be bigger than f of -2. You're not going to need that, but the more theory we give you, the better prepared you're going to be. But I found an error here, too. I spelled relative wrong twice first period. They almost got bonuses out of me. If I take that minimum of 0, do you agree the 0 would be there? If I take that minimum and plug it in, it's saying that my value should be less than f of that x at 0. This is not true for this statement because the max and the x, or the min and the x, can't be equal. So this guy really is not the relative min, he's just the minimum. But again, you're not going to have to worry about that. All right, the last little bit. Talking about theory-wise. Your max is where your graph changes from increasing to decreasing. So this is your max. It's where your graph changes from increasing to decreasing. I might be colorblind here because it said to shade it in green. So there you go. And here, this is where we go from decreasing to increasing. Well, that's the min, so I'm going to take that off. I was one step ahead and I did the wrong color. The min is where we go from decreasing to increasing. We never thought of it that way. We just looked at the maxes and the mins. All right. One more type of problem you're going to have today, and we're going to talk about this more tomorrow, is the intermediate value theorem. And what that says is if I have two y's, one that's positive and one that's negative, in between them I'm going to have an x-intercept, or a 0. We're going to work with that tomorrow. But you may, and I can't remember, I worked this homework a while ago, you may have a problem that gives you a function and says, explain why it would have an x-intercept. When that happens, if you plug in for your function the two values in the interval, these are going to be our x's, and we're going from x being 1 to 2. If my y's change values, that means we're going to have an x-intercept somewhere in there. If I plugged 1 into that guy, you do get a -2. If I plugged 2 into that guy, you get a 4. Is there a sign change there? Do I have one y that's negative and one that's positive? Absolutely. So that means that you're going to have an x-intercept between those values. Because remember, that fella equals y. You would only really need this if it's a really tough graph and I said we would not be able to use calculators. This is a tool that you would be able to use to help find your intercepts. So if plugging in your lower value of x and your higher value of x, if one is less than each other, that's what the intermediate value is. But that's really all we're going to do with that too, is introduce it. We'll see a little more tomorrow. And for the last couple minutes, we're going to just review a little bit on the last page. We'll discuss concavity as we go. But we are getting through this stuff. Doesn't this look like one of your roller coasters, maybe? Right? Except for the flat part. That's kind of boring. In calculus, you're going to use derivatives to talk about concave up and concave down. When you have a maximum point and a minimum point, you're going to see that you're talking about concave up or concave down. But we have done intervals of decrease and increasing a long time. Can anybody tell me between what letters we're increasing? There's two of those. What do you think? D to E. Yep. And there's one more. Somebody just shout it out. F to G. All right, perfect. What about the decreasing intervals? Can anybody tell me a decrease? Yes, Jared.
A to B.
A to B. And guess what? Since A is an endpoint, we're going to use a bracket. And there's another decrease. What do you think, Isabel? E to F. Yep, and there's one more even. G to H. But see how easy it is this time? When we talked about it, though, we just looked at almost the slope of the line. But now I want you to look at, well, this x of that point was bigger than that x. That's why we're decreasing. Yes? Mid-yawn, that's all right.
Is the last one G to H or
Yeah. So would we say, well, technically, would we say to infinity then? Is that what you're thinking? Yeah. Well, yeah, positive infinity. Okay. Yeah, that's awesome. I'll even be nice and give you a mistake point for that, because that was pretty astute. Yeah. Alrighty. Do you agree our constant is B to D? Not inclusive, though. We never do constants, right? We're going to skip the concave ones. If I added points on here, it would be the point of inflection, and you're going to learn more about that next year. But we're going to skip that. If you look at the key, it's going to show those. But the final ones is the max and mins, and then we're done. Do you agree the max occurs at E? Right? The relative max? Relative max is also going to be at G, because if we plugged in that maximum value, it would work. So we are talking about multiple maxes. And the min is at F. There's only one min. All right. Only the odds to finish the packet. I know this was a boring day, but we had to get through it.